Here is a stone sitting above the ground somewhere on a hill at a height which is given by the lowercase h. The W represents the weight or the force of gravity by which the stone is being pulled down toward the ground. If I wanted to calculate how much work I have to do to take the object down from here and lift it up to that height h, we learned that to calculate the amount of work done on an object, you take the force by which you are pushing or pulling times the distance over which you act. Now in this case, we're acting against the force of gravity. So if I wanted to lift the stone, I would have to push it at least with the same amount of force by which the earth is pulling it down, which is the weight of the object. And the distance here is the height to which I'm moving it. So the amount of work I would do would be equal to the weight of the object in newtons times the height of the object in meters above the ground. And it turns out that that value right there is equal to the amount of potential energy, gravitational potential energy, that the object has because of its position above the ground. So to calculate the potential energy, all we do is we take the weight of the object and we multiply it by the height. Now you remember how to calculate the weight of the object if you know the mass. You take the mass of the object and you multiply it by the gravitational acceleration. So mass times gravitational acceleration, that gives us the weight of the object, and then you multiply it by the height to which you're lifting it. So this is going to be the general formula that we are going to use for calculating the gravitational potential energy of objects. We take the mass times the gravitational acceleration times the height at which the object is.